People from online, good morning. Engineer Mike, Engineer Ibrahim, good morning. Yes. So we are going to start. Also last time, yesterday, we are going to start by starting the project. Now we are going to start with setting units as for other softwares. So you go to tools, here. We come here to Unity system. Tools, Unity system. Huh? Don't have tools? The last tab. Look at last tab. You got it? Yes? Okay. Then you go to Unity system, right? Then we will get this dialog box. Huh? Yes. See now? Online people, sorry, a bit I'm going to support. So you can use this dialog box. Follow please. You can use this dialog box. Otherwise, you can come here. You see, we have force units and you have length units. Also, you can enter there and change. Right? You can enter there and change. So for length, we are going to choose meter. For force, we are going to choose kilonewton. Then for dB, for temperature, we are going to choose Celsius. Celsius. Yes. Huh? Celsius. We have Fahrenheit and Celsius. So we will choose Celsius. So click OK. If you, but for it there's no need for that. So if you open the guides, we have the parameters that you're going to use here. Okay. Everyone has this guide. Huh? Yes. Huh? After entry system? Here? No. Just this. Except if we had there the units, then you want to change. Yes. So I gave you a guide. So I can't always disconnect and reconnect. We are going to use your guides. Me too, I have it in my phone. So we have a clear span of 5 meters. We have a thickness of side walls, which is equal to 0.35. We have a clear height of the box, which is 3.5 meters. We have a thickness of the deck, which is 0.325. We have a thickness of base slab 0.35. We have idealized top span, which is equal to, of course, the idealized span it is taken from center line of the walls, vertical walls. As you can see, we took the clear span plus a half of the thickness of the side wall times 2. Then we have height. Idealize the height because it is calculated from the center of top slab and lower slab. Okay. We have clear carriageway width. We have thickness of crash barriers. We have width of structures. All dimensions are here, right? So these are the ones that you are going to put in our model. Yes. Width of the span. What? Width of the structure. Because there is carriageway plus barriers. Yes. Good question. Yes, top and bottom. But they have them in their inbox. And but he had it in his inbox. Goki sent them to them. Oh. Goki is also So after having these predefined dimensions, we are going to do modeling. Of course, in modeling, first step is to define units, right? And we did it. The second step is to define properties of material. The third one is to go to set the parameters for longitudinal section, transversal section, and loading. Then we go to analyze as we did yesterday. Then we end up by design to check if our structure is able to withstand all roads applied to it. May we proceed? May we proceed? Invite us to send it to the book. Invite them? Consider it. Can't open WhatsApp. CEO don't like it. CEO don't like it. That they open WhatsApp during the session. Huh? So except if I don't show. Don't share the screen. What's the Okay. We are going to go to properties now, right? Let's proceed with properties. We go to material properties. We add material. We come to concrete. So here by default there is Euro code here. And yesterday you were telling me you want to use BS, right? But BS for this box culvert, when it comes to loading cases, we won't find it. The load combination of BS won't be there. Yeah. Except if we mix the standards, and I think it won't be good. So this guide is prepared for Indian standards. Material property you came here to add. You add material. You don't get what? Did you get it? So we go with Indian. Yes. You see? ERC. Yeah, ERC. IRC. Easy. At the bottom. Yes. The material, you choose M25. 35, sorry. Oh. ERC. No, IRC. Is there? Scroll down. Yeah. IRC. Okay, let me count support. Let me count. So you see, it calculates all the other properties of this material for us. It's M25, 35, sorry. M35, 35. M35, yes. It's a box. Are we done to define materials? So, as you can see, as I was saying, you see here, after inserting there the codes and the class of concrete, then the rest software is going to do it for us. You see all other materials property I created here, right? So now we can click OK.
Yeah, please.
Next.
Sorry. Yeah, please, sorry.
Yes.
Why don't you use instead of using Indian codes, why don't we can't we just adopt BS for this case or Eurocode instead of using Indian codes?
Yes, when you use BS, me too, it's the one that I would prefer. But when it comes to when you reach on the loading case, right? We have there for this box cover there are only two codes. This ERC and ASHTO. Then Indian BS is not there already, so it will require to mix codes, which is not good.
Okay, another thing, when we define loads, can't we just find, for example, if I find the loads on my own, and then I know maybe in BS, because for the box culvert, for us which are using BS, we usually adopt the loads from BD31. I think you might know it, BD31. Now, if I find the loads from BD31, and then I adopt safety factors from BD31.
So you know, if you know all the properties, right?
Yes.
You can come here, you choose none.
Okay.
Then you choose type of material here. Then you come here to fill there the properties of that material. Then you click OK to save as we saved there.
My point is, for example, maybe we have decided to use Indian code, right?
Yes.
Now, when you go to the, I don't know if we are going to adopt a method of modeling on our own from the scratch, or we are just going to use the wizards for box culvert. For example, we are going to model on our own from the scratch, right?
Yes.
Now, if you are going to model on your own from the scratch, that means I can enter my loads that I've calculated on my own, right?
Yes.
Now, the issue of choosing other codes, it comes, the difference always comes on the moving load. I'm not sure. I think Midas just maybe only on bridges, but for the case of box culvert, we cannot use the moving load from BS, right? Now, if I calculated the load from moving load by using BS standard, and I know for maybe a certain case, I think there are almost 5 cases to try, if not 5 to 7, but they range from 5 to 7. Now, if I know everything, why what I'm trying to say, why don't we just use BS? Because we have every road, and we know the safety factors. If we were using the wizard, that was the case.
Now we are going to use wizard. For this case, we want to use wizard. Yes. Yes.
Okay. And another, okay, when we come to the wizard, I'll ask you another thing. There's a problem. that I've always faced in Midas. I hope you are going to clarify it for me. So, will we use both approaches? The first one by using wizard, and the second one modeling from scratch.
Yeah, we are going to do it, no problem.
Okay, fine. Okay, thank you.
Thank you. Who was suggesting the name? The name of someone who was suggesting? Let me do it. Look. Hello? Hello? People from online?
Yes.
Who were we suggesting? Yes. Who was suggesting?
Nah, I was not the one. We can just write maybe just training box culvert 2024.
No, there is someone that I was talking to. Are you the one?
Me?
Yeah.
Yes,
the name?
I'm the one.
The name?
My name. You want to know my name? Oh,
yes,
my name.
Yes.
Bernard Kitosi. Bernard Kitosi. Yes, Bernard.
Let me write to Bernard, no problem.
Okay, fine.
So that when we are going to model the using nodes and elements that I will mention you. No problem.
Okay, fine.
Thank you for good question. So now the software is asking me to save. Okay, you see the folder is there. Just I'm going to call it box culvert. For me, I save it. Okay. So what I was telling Bernard is maybe I have my own the material that I know the name, and I don't want to use these standards. Like we were talking. Is that code? Is it? Okay.
Do you mean the code that I wanted us to use, or?
No, I'm discussing here in this room. There is someone who had a similar question.
Okay, fine.
Yeah, so I was about to let him know that without using these these codes that are here, these standards, we can choose none, and then we put there our own parameters here, right? And they work with our material.
Okay, fine.
Yeah. So now we have already defined it. We are going to go to structures. Let's go to structures. Structures tab. Structures tab. Okay. We go to RC frame box. RC frame box. So we saw that the effective span width is 5.35. Effective span width. So we have these parameters above. It is 5.35. It is calculated from center to center of particle walls. Yes. Then you see the material that you calculated already is there. Okay, yes. This is the one that we define it. Huh? So we choose two-dimensional. We want to be two-dimensional. First of all, box culvert. You were saying? What? Two dimensions. For span, I'm defining span. My span is 5.35. Okay. I was saying here, the material we defined, it popped up here. If it was not yet defined, there will be nothing. It would require to go to create the material. But because we created this material before, no need, it is there already. Yeah, two dimensions. Huh? Two dimensional, it will come like it will be a shape like this. Then when it is 3D, it will pop to show you the shape of 3D box of it. Okay. Then here for T1, we have to look at this configuration. You have to look at this configuration. T1 is here. T1 is here. Do you see T1? Here. The top slab, the thickness of top slab, and you have it above in the guide. It's 325, right? 0.325. Yeah, 0.325. 3.5, yes. T3. T3 is here. Do you see T3? It's the thickness of vertical wall. Huh? Thickness of vertical wall. It is 0.35. We go to T4. This one. Yes. Huh? Yes. Because the bottom slab. 0.35. This A is like hunch. So it is 0.3. Huh? Thick box covered. That's it there. Yeah. Yes. Huh? T4 is bottom slab. We saw that is 0.35. T4. It's like a hunch. You see, it is like this, but inside here there is a hunch. Yeah, chamfer. It is there in the parameter that I got. So, yeah. 0.3. 0.3. You have a guide? What's up? Is there? No. Look at here, where we are. We are following the guide. We have 0.3. A3, you see it is here. The bottom, we don't have it. Our slab is horizontal. Then B1 is here. That chamfer, the length of that chamfer, also it's 0.3. B5, we don't have it. Huh? B1 is 0.3. The sides of chamfer are equal. Then we come here to H1, you see? H1. B5 is 0. Yes. H1. H1 we have 4.175. 175. Yes. It is from center to center. Yes. Yes, yes. 3 points. Oh. Let's see. H. Yeah, top to bottom. Yes, yes. Top to bottom. Then H2 here. H2 is 0.065.
Engineer.
For this case, yes.
Engineer, sorry.
Yes, yes, I'm hearing.
Now, for the case of the box slab, always on top of the slab, there are several layers, right? For example, if you look at P, is I'm assuming that P is going to be the thickness of asphalt concrete or any wearing cause, and then
Yes.
H2, let's say we can term it as a fill, although it's a combination of different layers, right?
Yes.
Now, I don't know if you have tried it. For instance, there are some cases, if the value of H2 is less than, I don't remember properly, I think if it is less than 0. I think 0.6, always given me several problems that I cannot go far with the analysis. When I reach the point of analysis, uh, I cannot continue. It's like it always gives me an error, or maybe I don't know what's the issue. If it's either the code that I was using, or it's the software itself. So I don't know.
So for this case,
Mm,
actually, you see, in your situation, this
mm.
H2 would be a backfill, right?
H2 will be what?
A backfill.
Yes, 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 yes.
Then P would be the
Yes,
pavement layer, the surfacing layer, right?
yes, yes.
But here it is supposed that the backfill is not there, then the surfacing is already laid on the pipe carpet, so on the box carpet.
Wait. Uh if you look at the diagram clearly, you can see that our pavement layer, it's a part of our fill, right? That means H2 includes the thickness of wearing course. Am I
Yes,
correct?
yes.
And then you are saying, if the case that there is no backfill on top of your structure, right?
Mm.
And then continue. We are now on the same page.
You're not on the same page?
Uh, I was saying we are now on the same page. I've understood. You
Okay,
can
okay.
continue. Yes.
Okay, thank you. So the P also will be 6.5. Did you finish?
Wait. So that means on top of structure there is no any backfill. There is only wearing course, right?
Yes, yes. That's the
That's why you
case.
have put H2, which is similar to P.
Yes, that's it.
Okay. I was trying to say that, have you ever tried in a case that the thickness of layers below asphalt concrete, let's say try to put it less than 0.6, say, let's say H2 is equal to 0.5 plus the thickness of asphalt concrete. Have you ever tried such case?
Maybe you don't have a good internet. I'm not hearing you.
Can you hear me?
Yeah, now I'm hearing.
I was saying, for a case right now, you have put the thickness of backfill similar to the thickness of asphalt concrete wearing course, right?
Yes.
That means there is no any backfill below the asphalt concrete, right? Now I was saying, have you ever tried a case that below the asphalt concrete, the backfill, which is less than 0.6, because usually in BD31, the code that we use to design box culvert, for us which we adopt, BS is the one which we usually use. Now the case of treating a box culvert which has a backfill of less than, which has a fill of less than 0.6, it is different from the one that have a fill which is greater than 0.6. Now when I try to use the wizard in Midas Civil and putting my fill above the structure to be less than 0.6, I have always faced a problem when I want to analyze the structure. It does not analyze. So that's why I was asking you, have you ever had such a case whereby on the value of H2 to be less than 0.6, including the thickness of asphalt concrete? That was my yes.
The case that I tried, the thickness was higher than that, but that will be another experience that I want to experience to see what will happen?
Okay, fine. Maybe on your own you can try it, or
Yeah.
maybe if you can try it and then give me feedback.
Yes.
Okay, fine.
Thank you.
Thank
Yeah,
you.
excuse me, Mr. Engineer Pierre.
Yes.
I wish to ask, is it 0.065 or 0.65? Because I've been hearing Engineer Binadi speaking about 0.6, but you just wrote there 0.065.
For now, it is 0.065.
All right.
But for him, the H2 and the P, they had a difference.
All right.
So now we were defining the longitudinal section.
Sorry, I wanted to tell Engineer Mike. Engineer Mike, can you hear me? Engineer Mike.
Yes, I can hear you.
If you're familiar with box calavat, I don't know the approach that you use, but if you always adopt the approach from BD31, I was saying in BD31 there are two scenarios. The first scenario is when the field about the structure is less than 0.6, and the another scenario when the field about the structure is greater than 0.6. Now, the treatment of these two scenarios in the manual are different. So I was telling Engineer Gafis that when I tried to design a box calavat by using a wizard and the field about the structure is less than 0.6, I have always faced some challenges. That's what we are exchanging between me and him. But he said he has never faced such a case.
Okay, I understand that.
Okay, let's progress. We were defining the parameters for longitudinal section. Now we proceed with transverse section. What? Which one? T2. Yes. T2. But we have one cell. T2 will exist when you have multiple cells. Okay? HP? H2? Is it clear? Okay. Yeah, of course. As they explained to us, when the countries, when they have clients in the country, they may propose them to put their standard in the program, right? You saw there is South African code, right? Because they have many clients in South Africa. So like, if they have many clients here in Tanzania are claiming we need our son to be there, of course, they will incorporate. But currently, we are using the codes of countries where they have many clients. Yeah. So. Yes. Yeah. Let's proceed with the transverse section. Transverse section. Are you there? The next term. The next term. Question? Yeah, tell me. Yes. Did you finish to put the inputs? Yes, Travis. For Travis, we have type 1, then B3, you see, the barrier, crash barrier. So it has 0.45. B4, we don't have it. Type 1 here. B5, you saw that it's 8.75. I'm learning quick. Oh, so B4, we don't have it. 0. No, B3, it's a crash barrier. It has 0.45. Yes. Crash barrier. Huh? What? Before you don't have it. It would be for like a shoulder. You don't have it. B5 is the carriage wave. It is 8.75. B5. B6 also is like B4. It's not there. B7. What? Yes. The B3 or B4? Yes. It's like a cross section. Crash bar. You know, on the roads. Not about me. Don't continue maybe in a yes. Yes. Physics is like before, it's not there. So then now we are going to support. Support. Huh? Support. Downward. We have string type, general. Then for here we have a value for this. Is you see? Yes. Support. So we have 76. 30. Huh? We are going to support our box culvert, right? Yesterday we saw the different type of support that we can provide, the links that we use. Do you remember? On the boundaries, here we are setting the boundaries. So here you have the modulus of subgrade reaction. So we have the values okay. Here. Huh? Yeah, to give that. They are calculated here. I gave you the guide. The way it is calculated is there. So you can't go for every single calculation. Yeah, it's elastic. So the length of elastic link is 1 meter. Done? Done for everyone? Yes, the whole audience? From bottom to the soil. It's like, you know, yesterday, when you were linking our 2 points, do you remember? Yes, the way they were linked, the depth that we put there. What? But sir, imagine if we reach on everything and we go to explain what will happen. Can we end up this session? You see, we have a lot to do. Actually, if I suppose that you know these calculations, how to get there. So when I go to explain each and everything, we won't end up the session. We continue to loads. Loads, please. You go to choose code. Load the combination. Choose IRC 6.0. 2000. Huh? For material? This standard there, it's possible that we can go back, no problem. If you find it confused, the code, we can go back down the chain, no problem. So here, go to define moving road case, code, sorry. Moving road code, yes. So you go pick India. Click OK. Again, we have to define moving road code. Yes. Then you come here for safe waste. You have to input pavement thickness. Since you defined yours already popped there. For pavement, 20. Surcharges, if you saw we don't have surcharges, it will be 0. Friction angle will be 30. Friction angle. Yes. Friction angle 30. For subvented groundwater, you don't have. Can you check? For crushed barrier, so I want to progress. You want to discuss about today? Barriers. By the experience, the crash barriers are those safety furnitures that I put along the roadway. Yes. Yeah, they're calculated manually. The notes are there already. Because we don't have it. Yes. Yes. So for temperature system, don't have it. For temperature gradient.
Here, excuse me. Can you please share your screen?
Oh, it is not shared?
Yes, yes.
Okay. Now can you get it?
Now we can see you. Now we can see you.
Okay. So here for temperature gradient we have 17.5. Then for shrinkage strain we have 0.001 999, then 7. Triple 0.001 shrinkage strain. Thermal coefficient is 1.2. Exponential 0.051. Question? E? No, that's E. Yes. But you have a manual. You can use it. Are we together? Are we done with this? Done with this, please. So now you can click OK. Oh. Then let me open again. Where the name went? Maybe boss calculate modeling. Structure. .35. 65. This is happening. You see now the box carpet is there anymore? So online people, wait a bit. I'm going to explain for physical participants.
Hello?
Yes.
Yes.
We are back. We are going to proceed.
Okay.
Yeah. So we've created a box culvert with some loading conditions. When we come here in the tree menu, we go to work. We can see it's loading. Okay. Can we proceed? Did you finish to open your models? Okay. I was saying that we created a model. We defined the span. We defined transfer section, but also we put there loading conditions. Okay. So when I come here, if I want to display my loading conditions, go in a tree. Told you to go in a tree. Then you go to works. Yes. You see that we have nodes here, we have elements, we have material, the one we defined, we have cross section, we have boundary here for supports. If we display, you see, you remember this, we did them yesterday. You see that distance that you put there, the link. Let me display the link. See the links. No, you want to display loads like how I'm doing it, right? You go to this tree menu, you go to works, you enter there, then you come here, you see everything created is here. So I was displaying the supports, you see they are here. Yes. Which allows? These are links, not supports. The links linking this bottom slab to the ground. See, they're there. Of course. You go to self-weight element beam, display. You see I am in display, but if I display again, you see they are there. In static loads. Let me come supporting up. So you are proposing me to expand the tree menu, right? So that you will be seeing where I'm clicking, right? So for temperature gradients, if I display, you see the values are here. Temperature gradients, you see. Static loads, half pressure without water. Display, you see. Do you have confusion? Do you have confusion so that I can support? Huh? Okay. Sorry a bit, people from online. I'm going to support someone. Did you display the forces and see how they're displayed? Okay. Now, we need to add there the other forces, right? So we want to add there the other forces. So like what you were telling me, asking me about water pressure, things like that. We're going to see how to add the forces. Okay. We go to load tab, static loads, rod. Rod tab, static load. Huh? You don't know where to start? For previous, we didn't do anything, sir. We were just displaying these forces. If we went at the break having this model, like it was, we didn't do anything except to display the forces to see how they are located. For example, we were seeing how these supports look like on the structure, right? We came here to see the links like this. Huh? Are you in trees? Yes, you go to support, you right click, you go to display option. Yes, you see they are there. When you come here to static loads, you right click on beam, on the element beam, you display, the loads are there, they are displayed. When you come here to temperature, you see the temperature is displayed, and so on. That's what we were doing. Nothing else we did. So, yeah, let me minimize this tree so that my model can find a space, enough space. So, we are going to load tab, go to static loads, we go to static load cases. Load the cases here. Then we get the dialog box. So here, if you are modeling manually without using users, these wizards, okay, this is where you can put there your loads. For example, let's put there superimposed dead loads. Did it what? So we type there superimpose dead loads. Then here we choose dead load of component in the attachments. Then we add. Okay. We go to surface code. Surface code. Surface code. We call it surface code. Then you choose dead load of wearing surface and utilities. Yes, and utilities. Huh? Here at load type. And delete them. Huh? Surface what? Surface coat. Surface coat of layer. Huh? I say the surface port. POAT. Yes, which stands for layer. No, type of load is dead load of wearing surface and utilities. Yes. We add. We continue with half pressure EP. Yes. Surcharge. 1. Then for load type, I'm going first. Yes. Yes, you click add. Are you still on number 6? Huh? You see? Then operation, area, right road, surface, down. So for here, for EP we go to half pressure. Here for load type, we go to half pressure. We choose this one. We add. Am I working at high speed? Okay, tell me where we can start, where you are, so that we can go together. Which program? Now let's pull down, you are going to go step by step, right? Let me delete all these that I put there. So just follow. I'm going to put there superimposed dead load over the deck, for example. Honoring people, sorry, a bit. We are going to start together. Then here I'm going to choose the type for superimpose dead loads over the deck. The type is dead loads of components and attachments. I add, right? Huh? Yes. Then surface codes. Surface codes. I'm going to choose wearing surface and utilities. I add. Okay. The other one is half pressure, EP, LL, surface one, half pressure. I go to half pressure, of course. I click OK. We are going to put there 9. We are on 8. For this half pressure, the reason why we are going to put there 1 and 2. One will be on one wall and another one on the other wall. Here. Then you go to class A. Case 1. Thought I added, but I didn't. There are 2. Then I go to class 1. Class. Yeah? Did you read the note the they are both equals? Yes. They can get it. Yes. For sure. I'm going to choose the I want to choose live road. Live roads. Then you have case 2. Also you have live road. Yes. We have class 70. track. You have a as event R track. You have class events. We track. We track. Yes, yes. I'd like to know what is the difference in class A? Is it the same in the standard? Actually, I can't immediately know the classes, but you know, in the vehicles we have different classes, right? Like, do you know vehicle tracking? Yes. Of course, they are also beneficial. Have other types there. I mean, is what they do. Hmm? Here I have large vehicles only in civil city. So it's all about consulting the standards. Okay. May we continue with braking forces? Braking forces. Yeah. No, longitudinal. Longitudinal. Braking longitudinal. Yes. Braking longitudinal. Longitudinal force from right front. Then braking vertical. Braking rods. This one. Braking rods. Okay. Now we finish up with our loading cases. Yes, we do. Yes. Yeah, you froze. To the base of the year. See, the list is here. In tree. And then we are going to go in a tree again. We go to table. Yes. the table. We are going to replace dead loads. You are going to replace dead. Are you here in this table? Let me. We are here at works. Yes. Works. We go to static load case, dead load. Right? Static load case, dead load. You right click. Yes. Behind. Yeah, just let me know that problem. So when you reach here, let me know so that you can progress. Huh? Rotated. Wait. You were saying? Yes. So we are going to click here at element beam rod. Yes. We right click. We go to what can I do? But I've been waiting. Not property, let's say the table. Do you get the table? So
Engineer Peter, we cannot hear you.
Sorry, we cannot hear you.
Engineer Pierre, we cannot hear you, sir.
Hello? Hello? Oh, that's sure. Is the point clear? Is the point clear? The reason why we are sorting the forces. So if you remember well, for superimposed dead loads, we consider the components, the dead load from component, right? Then we selected the dead load from component and the attachment. Then for surface ports, we selected the dead loads from wiring and utilities. Okay. Before it was concerning only the dead loads from the deck. So now we are replacing them. Yes. ACDL superimposed the dead load. So we considered the forces from structure and its attachments. Yes. 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 For dead loads only. Yes. 4? No, 2, 7. The others are the half pressure. See? I said, see, where we have dead loads, we are mixing this dead loads from the component and attachments, and surfacing loads and utilities. They are what we are considering. Are you confused? How? Tell me the issue so that we explain and we move on. I'm choosing SDR, superimposed dead loads, and surface load. Yes, I interchange. The point is this: for beam rod or beam element, the dead load there, we had the dead load of that slab only, right? Now we added there the other forces. We define that for superimposed dead loads, it will take the component and the attachments, right? Which means that even the dead load of the slab is included there. And you created surface cost. We define that the force will be the wearing costs and utilities. Is that clear now? We exchange SDR and surface cost. Number 127. No. For number 1, we keep SDR. For number 2, surface cost. Yes. Surface cost. Yes. SDR. No, SDR. We are extending 2 forces. Up to 7. Yes. No. Yes. So here we have dead load. We are displacing the term dead load. Huh? But you saw in our structure, we have different elements. Don't. Okay. As I have finished it for me, I can close. See, what these are elements. These are elements. Yes. 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 So that is when we come on this table to this element one, elements. Yes. That's what was missing, right? That's what was missing. Yeah, but you see, it has a logic. What you were doing, you see that it has logic. Yes.
Peter, can you please unmute?
Engineer Pierre, kindly unmute your microphone, please.
I hope you are hearing.
Yes, now we hear.
Okay. So, did you see how we were changing the loads in the table? Yes?
Yes, we did. Yes, we did see.
Okay. So, here you have 7 elements. Okay? So the next step, we are going to close it, no problem. You go on the table like this, then close. Yes, close. Do the close. You can close them. So, the next step you are going to apply. This is another Spider-Man. Can we go to load? And yes, you are going to apply the up pressure load. First new load, we go to the line. Then beam load.
Excuse me, Mr. Pierre.
Yes.
Can you please repeat the procedure? Because for a while here, we did not hear you, for those of us who are online.
Yeah, I'm saying we are going to apply half pressure load on the vertical walls of course. I went to load tab, I went to vertical line, then rod. Yes. Yes. You there? Let's go to load the case name. Load the case name, please. See, it's a uniform load. Yes. We are going to choose global X. Let me show you these things related to these nodes. Let me see the nodes. I'm going to show you. Okay. I wanted to display these directions so that you can know why I was choosing this one or this one. We go to display. I want to display. I go to elements, choose local axis, then I apply. You select local axis. So these axes are the one that we say we are going to apply from Z, from Y, or from X, depending on the direction where I want the force to come from. So, but these are for local axis. Now we are using global axis. Element number, if you want it to appear. But it's not going there even when you click here on this one. This one. Huh? Not same. You see, you have here node number and the element number. If you want to activate nodes, node number, you see. If I want to select, these are node numbers where the elements are meeting. Then, if I want to select the element number, you see. Hmm? Click the save. Yes? About what? I repeat, about what? Because we did different things, I can't know what you didn't answer. What do you want me to repeat? What? What do you want me to repeat, sir? To get that tree, I went here in the road tab. I went to line. Yes. Hmm? Yes. What? Weight is 12. Yes, weight. That is 12. It's 40. 40 of 12. Yes. Four? We select this one. Yes. No, 9 to 11? I have 8, 9, and 10. Nine, 10, 11. What's content is this side? This wall. Select this wall. No matter what coordinates you have. This wall, the left wall. We are applying on this left wall. Using the what?
Elements, it's 1 to 8, 1 to 7, but the notes, the top list, it's 1 to 8.
For me, I'm choosing the elements, not the nodes. Yes. Oh? Not for running that. Hello? So we go to pick the tag 2. Then we select this one, we apply. Oh, this has minus. I apply, I will get my false. Yes, both sides. Yes. Do you get the point? Okay. For this one, for this case, so here, we saw for the first case, we select this vertical wall. Okay? The up pressure, here it has the same magnitude, but due to that you are using this global X on this side, for directional force, we are using the global X because they are coming horizontally, right? Then for this one, we have chosen positive. We put there the positive values 12 because it is going in a positive direction. Now for this wall, we want them to come in negative direction, right? Okay. For now, if you read the guide, above there is where we calculate the dispersion area of the tire. Do you get it? Huh? We are going to apply here the load case for vehicle. Then I'm saying, yes, what I'm saying, we have what we call dispersion area. Yes, dispersion. When a vehicle applies a tire on a pavement, the force are dispersed in triangular shape, like a foundation does. Okay? Yeah or not? Yeah. So here we have, above we have the calculations, then we are going to apply on that area. By now, we are going to line beam rods. How many people? Excuse me. if you remember well, the starting point for us is this one. Okay? So here you saw that I used 12 positive sign just because I want my faucet to hit this element but going to positive direction. Okay? Then here on this side I put their negative because I want my faucet to come in negative direction along x-axis, right? Now maybe on my side I don't want to exchange those signs. I want to use 12. I can set my local axis so that my x will be coming from here going there. Okay? Maybe I want to put the buoyant force here, right? Maybe I have forces pushing my slab up. I have to set the direction. So how to do that? You see, I can come here in local. Let me cross this force, for example. You see? You see, like this one that I have. Maybe I want to change. I will select these elements. This one. Oh. Let me display again. You see? Maybe I want to change the coordinates for this. Then change the parameters, not the elements and parameters. Then I go to element local axis. Then here if I change angle, then I apply. You see? Yes. If I change at 180, let me select them first. So, see, this is very important while you are loading structure, because if you don't keep in mind these directions, you are going to be confused, or you will be putting their result, you will be putting there the loads, then they go in the wrong direction where you have the control. Okay, let me display my process. Let me display another one. So here, remember I was using global coordinates, the one that you know. The x is going like this, then from different points going to right hand side, I'm going to positive direction. From different points going to left, in my negative direction, just like that. So if you are loading the structures, you have to keep in mind those directions. If you don't want to follow the global coordinates, then you are going to set your local coordinates. You set y in the direction that you want, you set x in the direction that you want, and z in the direction that you want. Okay? Now We are going to load. Let's proceed by loading. Let me remove these local axes. Even this one. So we are going to pass through line. We choose class A case 1, class A case 1. Yes. Yes. Class A case 1. Class A case 1. Yes. We pass it through line. Yeah, line road because want to put the charges in the line element. So on the loading line, element selection is loading line. Okay. For Z, the relation is Z because they're using global always. They're using global, so it's in Z because we want to load here on top slab. Okay. Then we are going to set the distance. Distance 1 is 1.56. For X, we are setting X distance. Because we are coming from the different points going to where tire is. The tire magnitude is dispersed, the area. 1 into 1.56 to 2.59. Yes. Average of what? No, they are calculated. Huh? Let me check. Okay. So you see, all calculations are here, right? You see this 600, it's the minimum clearance from slab edge. Yes, this 600, you see what it is. Minimum clearance from the slab edge, right? Then you come here. Those distance that you are calculating, the dispersed area that I was talking about is this one. Yeah? Suppose here I wanted to show you where 1.56 is coming from.
So the minimum clearance from H is from the north to the
Eh?
and then from the beginning is that minimum.
From slab edge is here, right? Here, at the edge of the slab. Yes. That's the minimum clearance distance. Then you are going to take the hook distance, this one, minus that 600, right? You get me? Yes, minus clearance, then minus this distance, this dispersed the area, divided by 2. So the load is applied here, at the center of the tire. Then we get this 1.56. The same applies for this one, we calculate like that. See? It's 1.56 plus the dispersed the area. Here. Yes. Then the weight. It is dispersed the area where the tire magnitude will be applied. So we put there the value, and you know that we are working on the global Z. So because it is global Z, we have to define the direction. If you put positive, of course, they will be going up. But for us, we want our loads to go downward. So it's for 8.05. Yes, of course. Okay, let me first define these nodes. I will go to nodes, translate at it's 1.56. Then I select node. I'm going to translate these nodes so that I will know from which node to which node. Okay, listen the logic. Listen the logic. You see, to apply these loads, the load that I was about to apply on this beam, it is required to connect 2 points, right? Then I'm not really sure that the point I will pick on here on this beam is on that exactly at that distance. So to be sure that the node I'm clicking on is the exact one, it is required to translate the nodes accordingly. Okay, that's why I go to node elements, I click translate, yeah. Click translate, right? I go to set distance at x. Let me delete this one. I have 1.56, right? Comma 0, comma 0. Then I select the node that I want to translate. Okay. Then I apply. You see, it follows here. Translating. I selected the node that I want to translate. Then I click apply. So you see, it falls here. Okay. To translate it, you are lost. Let's go together now. Okay. Let me rename the nodes. Now I have these nodes where the slab ends, right? So for now, I want to translate. Translate. To reach here, you have to pass at node element tab. You come here to translate, right? Then after clicking there, they take me here to the tab node, here in the menu. Then I come here at distance. Then I set there that distance x, where I want to translate that node exactly at that point. Then later, I'm going also to translate this node at 2.59. Of course, I translated the first node, which is located at 1.56. It went here, this node 29. Okay, follow the process. Please follow the process. I translated. They give me this table in the application menu, right? Now I know that at X, I want to apply my node to the distance, which is equal to 2.59, right? At X axis. At Y, I want it at 0. At Z, I want it at 0, right? Then I'm going to select this node that I want to translate. Okay? Because the distance here, as I told you yesterday, we apply those live roads on vehicle having a different line. So we are referring to this node. But I can also select this one if I want, because we saw that 2.59 is equal to 1.56 plus that distance of 103, right? So if I want, I can select this node, then I translate it at that distance of this passed area. But because I want to take this point 1 as the reference, I'm going to select this one, then I send it here, see? So when I'm going to apply that road, I'm going to connect this node of 29 to that. This card? Me? Oh. Mm. 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 Yeah.
But the way that it cannot,
Mm.
my node is exploring I cannot, the first node is expressed on element one.
Yeah. Element 1. Yeah, that's the. So now we have the points of dispersion. Right. Ah. So this would be
Engineer Pierre, can you please unmute your mic?
Oh, sorry. So I was explaining how these distances were found. Okay? Are you hearing?
Yes, yes, we can hear.
Okay. How? Didn't tell me. Yes, but when it dispersed, yes. Yes. Ah, yeah. Uh, yes.
Excuse me, Engineer Pierre.
Yes, yes.
Can you please remind me how to make this nodes number visible?
Node number visible?
Yes, because
Nodes.
mine does not show.
Yeah, you see. Here.
All right, thank you, thank you, thank you.
Yeah. So after marking this number, we can also set these distances. We mark this distance. Huh? No, wait. We are going first to put there this number, these nodes. Then later we apply the weight. Okay. We go to translate again. Here you have 2.76. What am I repeating things we did? Did you create first nodes? You created. Now you're going to create the next ones. Yeah, it's absolute.
Can you please unmute your mic, please?
I see.
Junior parent.
What is it? What is it?
Please unmute your mic, sir. Engineer Pere.
So you're going to put there 1.6, 2.59 minus 48.05. If I put it up there. Yes. Now score 8.05.
I have a question there, Engineer Pere.
Yes.
I have seen that you have only translated the nodes for 1.56 and the next one, but not all of them.
Yes, I know.
Is
I
it
know
how
that-
it's supposed to be?
No,
Because
we're
so
supposed to have these four.
all right.
Yes. But the process of translating these nodes is the same, because I was
All right.
checking that they will be applied there.
Okay.
Load the case one. For all of it is not working? For all of it is not displayed. No, it is not displayed. The forces. Not displayed. Actually, okay. Let me explain this first. You see, for these forces, I use line plus. So what we were creating is to see how we can translate those nodes from the starting to their original positions. These ones, right? It would be one method. But another one is that when you set those distance here, like 1.56 and x2 2.59, okay? Then you're going to select the nodes, node number 1 and node number 8. Actually, it will know that distance, then it will pose those forces there. Okay? Not necessary to go to translate those 4 nodes. When you just put there this distance, you apply there magnetic force minus 48.05. Then you select from node 1 this way. The node loads. Node load, okay. Yes. Okay. So you would come here and join, then you will know the exact load. So let me search how we can display this force. Go to display. I go to load. Load case. Load case 1. Want to know the loads. I'm searching how I can display these forces. Search operation. For breaking is okay, but for this case, see, this one is working. So I was checking the issue if it was on all load cases there or if it was on that load case one. So I tried to apply there braking force in the longitudinal direction. You know, when a vehicle reaches on the bridge, then the brake takes brake. There are additional roads on that bridge. So you see here, I put it there, but you see it is straight. So I have to check with that loading case to see what's wrong with it. Yeah, so let's go in a break. Then when we come back, we'll continue with this. Okay. People from online, it's a break period.
Okay, 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 okay.
Hello again. Ibrahim, Bernard, Geoffrey, how are you?
Fine, we are fine.
Okay. We are going to resume our session.
Okay, we are ready.
Yeah. So, before we created these nodes,
Please, don't forget to share your screen here.
okay. Forgot to share. Now you see it, right? Do you see it? Hello?
Okay, I see it now.
Okay. So, now we are going to proceed by loading our structure. So, for row case, we go to line element, then we choose row case, come here, we go to Z, absolute value, 1.56, 2.59, then I connect two nodes. Can't you show it? Or the value of the load. Now see the load is applied there. Yes, that can be absolute. Then select the nodes. No, just click there and click the swap. Click the nodes. No, not necessary to select. It's not necessary to select. No, I'm here to the nodes. No, the nodes. Click there, then and select the selector. That one, the cycle. Yeah, select. Then click there in that point. Yes. Pick the point 29 up to 30. Yes. Now. Not yet. Oh. Why not?
Oh, I need to open it in the code.
Yeah, close it and reopen. So we're going to put there. We're going to put there this value in x1. In x1, then in x2, people from online, are you following? Are you following, please?
Yeah, we are following,
Yes.
but
Yes.
this load mark does not appear from the side here. Don't know why.
Does not appear.
Yes.
This one.
Yes.
Oh, also for me, before it was happening, then I closed the software and I reopened. Then when I applied it worked. So
Let me try to do this.
Now you see
from the reset.
you are resetting. Okay.
It's not a small mode.
Okay. So when you finish, let me know so that we can progress. Right?
Okay. Okay.
Engineer, can you please unmute your mic?
You say?
Can you please? Your mic was in mute.
Yeah, but I didn't say anything.
You wanted to
I was supporting the others.
All right,
Yeah.
all right, I get you.
Yeah, I see. We are at the same stage. Are these roads disappearing?
For me, they are.
For you there?
Yes.
Good.
Okay.
Hello.
I'm hearing you, sir, Ibra.
Still, this loading does not appear here. I don't know why.
Oh. Let me close it and we go together, right?
Okay.
I'm going to delete it and we are going to go together. We are going to roll the tabs.
Yes.
We click on line beam rods here at line.
Yes.
We get this dialog box. We select our class A, case 1.
Class A, case 1. Yes.
Yes. Then make sure it is uniform rods.
It is uniform volume. Okay.
We come here, we have global Z.
Yes.
Make it absolute.
Absolute.
Yes. Then 1.56. The first point.
Okay. Yes.
The second point is 2.59.
Yes.
Then the weight of the load is minus 48.05.
Yes.
Then we are going to click here, nodes for loading line.
Yes.
Select from point 1.
Yes.
We move to node 8. You see?
Okay. Yeah, I see now.
Yeah.
Okay. I don't know where I mistaken. Yes. But I see
Right.
now.
Yeah.
Thank you.
Yes. But remember,
Yes.
this is a dispersion area for first tire. We are going to apply a load which occupies the dispersion area for second tire. You see, we have 3 points. The load we set is between these 2 points, this one and this one.
Yes.
Now we are going to replace point 3 in place of, we are going to put point 3 in place of x1.
Yes.
We take the value of 0.4 in place of x2.
Okay.
Oh.
Okay. All right.
Right?
Yes.
The same magnitude. Then
Yes.
I select my points from 1 to 8. You see,
Okay.
the loads from the second tire is applied.
Yes, I see now.
Yeah.
Okay. Thank you.
You can cross. What? Yes. This one. 2.76. 76. Ibra, do you still have a question? Because I see you are raising your hands.
Oh, thank you. Let me lower down.
Okay.
It's okay.
Now we are going to apply the braking rods in longitudinal direction. In longitudinal direction. Line beam again. Braking longitudinal. Braking load case is braking longitudinal. Line shot. Load case is braking longitudinal. Yes. Yes. Of course, the direction will be X. For me, I wrote braking longitudinal. I don't know how it's called. Okay, if you don't have it, you are not able to differentiate them here, you can go back here in tree, work tree. Look at the projector. See, we created two braking forces. Yes. Braking longitudinal and vertical. We have longitudinal and vertical. Not together. Okay. Tell me where you are. It is on top of the bed. You understand? It's a braking force. The car is braking while it is on the bridge, right? So if it is braking, there are additional forces which are applied on our deck. Yes. It can't be like that. You know what? Get the rods. No, go this one. Yes, close it. Yes. Then this one. Yes. Isn't it the one you created for creditors? Yeah, delete it. Yes, delete it. Then start. Line. Then come here to Leadicus one. Then come here. Two. Minus. Five is over. Here. Yes. Then wait. We're going to request this point. Request this point here in X1. Yes. Type 2.76. Then it's to 3.979. Yes. It's okay. 1 to 8. Click there. Oh, click there. And It was in a distance. Yeah. Pardon? Okay. Are we together? We are going to click online, right? Because this load that you are going to apply, breaking line in longitudinal, is the load which is going in the longitudinal direction, of course. Okay. Then the axis that you are going to use is x, because it is moving horizontally. Okay. No, for us we are going to choose x. Yes. It's global. Lost. Yes, it is uniform. So we are together. Okay. Now for x1 is 0, but for x2 is 5.35. Yes. Huh?
5.35 years back.
Yes. Then minus 2.998. 2.998 is calculated. Hmm? Hmm? It is working like this. Width of the span. Clear span. Yes. Huh? The load. Yes. It has to be applied on the span. Huh? The load is coming this way. Don't you see the arrows? Huh? Yeah, depending on the length that you consider, of course. Yes. Absolute. Hmm? Hmm. The direction, I'm considering that it is coming this way, from positive to negative. But of course, as the colleagues is saying, we have two lanes. We may have two lanes. Not selection for this breaking line. It is from first node to 8. It's going like this. Which numbers? Of course. Go to the check there. Yes. Because it's 2.9 is 998. Yeah. Huh? Yes, that's what it approximated. Then you are going to breaking vertical. Breaking vertical. Break vertical. Break vertical. Yes. The effect of breaking force, but in vertical direction. Huh? Yes, the impact is going to have on the right. So there will be trapezoidal loads. Absolute. The distance is that one. .35. Then minus 4.801. Yes. Trapezoidal rods. Trapezoidal rods. Huh? So of course, if it breaks, but there will be one side will be receiving more forces than the other one. No, don't see them. It is uniform. Yeah, the clear span. Yes. -4 for first point. It's -4.801. Then another one is the same magnitude, but the difference in the signs. 4801. Yes. Do you have the same results? Yes. Let me count.
Can you please unmute your mic, sir? Engineer, please unmute your mic.
We put there the class for vehicle. Yes. So it will be standing for the others. So let's go to perform analysis. Yes, yes. Oh. No, that's part of the session. Mm. Let's see that in the table. I have that. The cursors are here. See? You know what? Mm. Let me say that the same is one. Is better than others. I can see here this event R. We have greater values than this one. But just when we are teaching, of course, you see, we were seeing how we can apply these rods, right? On the deck. We saw how we can do that, and we apply that in the center, as you were saying, where we get highest learning moment. So if we want to, of course, we can, in search analysis, the how do you call it? The analysis of moving loads. It may be located somewhere or somewhere. So just by knowing those locations, you can apply those other loads. Okay? Yes. 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 2.15. Yes. These I can say like effective one. Yes. The space in order to. Yes. Yes. Okay. Which question? No, that's what this one he was explaining. The distance between the tires is very close, and when they're like that, it's when we have effective loading. You see, if the tires are so close, those triangles are going to meet. Highest magnitude. Yes. See it. What? For braking? But there are other calculations for braking. You see the braking effects calculations. Can you see the braking effect is here? Is calculated here. And the next graph. X1, X2 for braking load. But it is applied on the whole distance of the span. For braking effects. Yes.
I'm talking about one and two. 4.8 it is the load. Wait. I'm talking about the sound. The sound is 0, the 2 are kept for the whole week span, but you're supposed to keep 1 liter. So maybe from the concept of the maximum volume.
Yes. Yes. So you mean that we would apply this braking effect? Yes. 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 Yes, side wall. Even when we are creating these sections that we are using, we go in that logic. Yes. No.
Please, can you unmute the microphone?
During the analysis or when? Huh? Odds? Hmm? Okay. We are going to perform analysis now. Hydrostatic pressure. Yeah, she was not here in this case. Yeah, it was not here. But also, if we want, yes. Yes, pressure. Yes. They are different.
Yeah, you have left us behind for those of us who are on virtual.
You say?
You have left us behind because your mic was on mute just after finishing the breaking load.
So we didn't do anything greater, right?
Yeah, I can see, but can you please catch it up to speed because we just see that you have started in analysis.
Yes, we finished the loading. Okay?
Yes.
We finished the loading. Then we are going to perform analysis. Do you remember where we passed yesterday to perform analysis? Do you remember there? Okay. Got it. Do you finish the run analysis? Yes. We go to results. So the combination. So the combination. So the combination. Here. So the combination. Yes. We perform the analysis. We go to yes to the concrete design. Yes. Find that you have these are the cases. Yes. No, concrete design. Yes. Sorry, a bit, it was the program the power. Are we together here? Are we together here?
Can you please share your screen? Did you appear?
Yes, yes.
Please share your screen.
Let me share. Do you see the screen?
Yes, now we do see.
Okay. Do you have this table?
Yes.
Do you have it?
I do have it.
Okay. Complete. You're incomplete. Are we together there? Okay. We are going to click here on generate, auto generation. Yes. So let me do that. Yeah, let's see 6 LSD. 6 LSD. SD. There, done. LSD. Oh, it's not complete design. So LSD. Oh, not still design. It's not a still design. I say no. It's just a code. It's an Indian code, of course. Yes, it's a design code. So click OK. You click OK. Yes. 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 Then we close.
How can you add about
What the other cases, all the cases, you click there in that arrow. They're there inside. Yes, they're there inside. Huh? What else? But you don't understand.
Excuse me, Engineer Pierre.
So once I get the other process, get the roads and put them there. How? Let me project that there. When I go to load the combination, for example, here for all the cases, I can put there the other forces. Let's put them all of them, no problem. You add one by one. So, and now for loads, we have safety factors. Okay. If we have like so, here you have loads, right? We have road case, but you have where you can put factors. You know, on the loads, because we can expect that the load at certain moment may increase. For example, the safety factors. If you want, for example, for live road, especially for live road, may put there like 1.5, for example, because they change. Huh? You know, for structures, you know, we are designing structure. For example, those walls or slab. We propose design mix. We propose the strength that they will have after construction, but due to poor workmanship, poor design, maybe segregation of materials during transportation, poor curing, they may have less strength than what we were expecting. Okay, so in that case, we can put there the safety factor of 0.8, for example, right? But for live road, we have to increase for safety. If we are designing it like this lab, for example, we say that maybe it will be a classroom. Okay? Then we say that maybe the kilograms of normal person, maybe it's 80 kilograms. But there may be one of 120. So that's why here we have an option of putting there those safety factors. Yeah. Depends on standard, of course. But mostly for live roads, the safety factor varies from 1 up to 1.6 from BS. For live roads. Why? Yeah.
Can you please unmute your mic?
What I was saying is this. By going there to the load cases, we are going to select the roads that you want to generate, right? Then we have the list of roads that we created, and we have the space for their safety factors, right? So for now, there's no need to say we are going to put there this and this. At your work, depending on the standard that you are consulting, there are proposed safety factors they talk about at every single road case. In that moment, if you are in your project, you are going to put there those safety factors. Just what I'm doing is to show where all those things, all those scenarios can be done from. Okay. Then we come here at the actions. We go. Yes. After making load the cases, of course, there are things that have changed. You have to regenerate. No. We perform analysis, sir. If you find it is not active like this, right? Huh? You know, listen. Before we had load by load, okay? We had load by load. Now, before we go to results, we went to design. We've chosen the standard, and we've chosen the factors. Maybe we've chosen the factors. The safety factor are no longer one. Maybe put there the other values. Of course, all those are going to be applied in this structure. So that's why we need to perform analysis again. Okay. Then we go to results. For me, I performed analysis. The reason why I come back here, it was to show you. If you see it is not active, you have to change here. Perform processing mode. Yes. You see, when I come here, when I put in processing analysis mode, sir. Of course. That's what I was explaining. It is here. It is in the post-processing. So in that case, you want to be active. So I come back here, put in the processing mode, the perform analysis icon is on. You can perform analysis. So here is what I was saying. Excuse me. Sir, you get my logic. Before we loaded the structure, right? Then we performed the analysis. Then we went to load case. We created the load cases. As I said, we put there maybe safety factors. Of course, there are changes that happen to our structure. Okay? That's why we need to perform analysis so that the results that we will find, they will be updated. You close because to get that table you auto generate it. You are going to see the results. Yes. You need perform analysis. Huh? Yes. No, go to perform analysis. See, to the lungs. Yes. Huh? Yes, Lord. And when it is still in this mode, listen, when it is still in this mode, you can't find the result. So I have to come back there. Hey.
Everyone will be the next
You know what? But are we together now? Are we together and you understand the reason why we are here? Huh? Not yet. Okay. But stage of loading was clear, right? The previous stage of loading was clear. Okay. We are going to run to see the results. I come here to reactions. I choose reaction versus moment. I come here. I choose legend and values because I want to see them. Yes. Then I apply. You see the reactions. Which color? Which color? Which one are you talking about? Red color. The reason why it is red, it's where we have maximum shear force. So it has to be indicative, right? So that everyone can visualize it. And maybe you can like yellow, another one like maybe blue. Did you actually? So the value is 29.4. Even here you can see here the legend here in the legend. So I come here to table, then can see the dead loads. You see the results of the forces. Okay. So let's see the shape and deformation. Loss. Reactions.
Some are 20, some are 17. 20, some are 7. Some are 7 here, and 2.3.
Yes.
Some are 3.
Hmm? You go to deformation. Yes. Reaction. Those are reactions, not force. They are reacting from the force which are applied on them. Hmm? You see? You can see. Yes, to deformation. Let me quit and start because the two deformed. Let me come bit and we start together. Yeah, for contour, it's another type of deformation which shows there are contour colors. There are colors which are indicating which is the highest value accordingly. This is fine. Yes, when you, huh?
Yeah,
Yes,
please
yes.
share your screen.
Let me share again. Yes, when you click on, did you click on the mirror? Oh, it creates another share, another share. And check it under privacy. So you see the deformation, how box coverage is being deformed. Huh? Yeah, it's a shortcut. Yeah. You man, you like joke. You like joking. So you see. Mm. I choose the deformed shape. Yes. Then one thing. Did you check values are not deformed and regent? Huh? Under deformed. Under deformed. Okay, even mate if you want. So you see. Then now you can see. You see? These are values of displacement here to the region. Huh? The colors I shown the maximum point. They have rates, means that they have max. We are going to see the bending moment values. We go to forces, then beam diagrams. Then we apply this. If you want to increase the scale, you can do. Huh? I change the scale just to exaggerate the results. I came here to scale. Yes, but I see it's too much. Like 2, for example, you see. Huh? To exaggerate the scale. So of course here it's like in the other software we can exaggerate the scales. Oh, yeah. Online people, excuse me a bit. Want to get the tables, can come to Beam, then forces. Then I select which forces that I want to run, for example. Then I will see the results. I come to table, I come here to beam, then forces. Like that. Table, beam. Huh? Result tables. You are in results? Beam. We go to force. Then we get the forces here. Huh? Of course, you have to select the reaction of the forces that you want to see. For me, for example, I remember where that I selected SIDL, surface 1, EP. Yes. Okay. Copy them and put them in Excel. Yes, just move like this and see it today. But when you select like this, can't you copy? You copy. Okay, sir. Huh? How can we detect them? That's what I'm doing. You see, I take the table and I copy it in Excel sheet. Is it here? Or you needed it somewhere else? That table. We are not on that stage. It will come. I was thinking you are asking how to get these results out of that table. Yeah, sorry for that. So for reports, we are going to reach the program. So, do we all have this spot, this table? Can everyone access on this table? Okay. Access on this table. So if you want to leave it, you just click here on the tab. On the window, you close window. Okay. You click here. By clicking here, the table will be selected. Then you right click, then you copy. Okay. So to leave this table or to go back in this window, if I want to keep it, I can just come to another window. But if I want to remove it, I can right click on this window here, then I click close. So we are going to design so that we can get that report you were asking about. Okay. We go to design. We come here, choose LLC, design. LLC 24. So I think this is the question that they were about to ask. Lost? Okay. Three many is lost. You click here, right click, then you activate. Again. Yes. You go to design. Come here to choose IRC. I said IRC 24 2010. Yes. Still lost? We are going to search for still enforcements. We are going to choose RC design. Did you choose here on? Yes, here on RC 2011. Yes. Yes. We go to design. You see? It's not current, but here I see it's the one which is updated. Here in software, isn't it the latest one? 2020. Okay, I can pick it. No problem. Yeah. Okay, we come here to let me check for safety factors. No composites. So I can see here the factors are there. Let's check first for here if you want to modify. For modification, go to modification. Here. We are going to here modify concrete material. We are here in design. Yes. Come here to modify concrete material. Yes. Get this dialog box. Select that material. Then we modify concrete material. Any code? Just I went to check if it's the one which was there. It was there. Yeah, it was okay. See, it's 20 that is there. Except if I have not chosen it here on top, that's when I will go there to choose it. Yes. You are only modify concrete material? You are on the concrete material. So the reason why we are here, we are going to choose the steel reinforcement class, right? So we come here, we choose the code. We come here, we choose the strength of the main bar, IRC. Yes. It's there. So for many bars, we choose highest strength. Then for this one, for grade of subbars, FE500. Yes. For subbars, we have FE415. Yeah. Then I click on modify so that FE for subbars. Yes. 415. It's M3560 there already. Then we modify, we close. We go to design. Yes. Did we finish the first step, please? Yes, RSC. May we proceed with the next step? We go to RC design. We come here at concrete design. Concrete core design. Yes. We choose beam design. You go to LSC design, please. Scroll down, concrete core design. Then you're going to design for beam. Rebar or design a concrete beam. Ridge. Let's select. You can select also by member. Then we can see the graphic, the materials that they are proposing. Graphic here. Yes. I selected. Remember here. Yes. You tick, just you tick. Tick here. You are lost? Yes, if I want to analyze all of them. Yes. After that, you see you can analyze, right? We can see the graph. Okay, you see the graph, and we can see so here. Now, this way I told you that you can check if our structures have passed or have failed. Here, this one, you see here I have or. You see here I have arrow. Yes. When you click on them, it expands. The table expands. New. For you don't have red. If it's blue, it means that your structure has passed. For me, you see, when I click here at OK, the reason why you see all these, when I click at OK, you see there is no structure member that has passed. Yes. When I click not good, this NG means not good. You see? Okay, first of all, I have to go to check on my loading condition if it is okay. Right? Loading condition. That's the first. If the loading condition is okay, I will go to silver reinforcements. If I find it's okay, I can go to dimension of the cross section that I used. Others?
Please unmute your mic.
Let me check for section data inputs. I went to section. I came here for beam section data for design. Yes. I want to check all these sections. Disable reinforcements. 12. Number. RC design. Yes. 4. There has to be 8. Yes. Let me come back. You came here for beam section data for design. Okay. I come to still-ups. These are still-ups. I have to choose size of still-up. I put there P8. Yes. Let me put there one, for example. It is for concrete cover at top and at the bottom. Yes, cover. 0.05 meter. Yeah. 0.05 sure. For top, can be 0.T 4 0.5. Yes. I put there one random mate, see, of still-ups. I put there 8 for still-up. I put there 8. I added under the press. Yes. Huh? I selected the all sections for me. So I selected all sections. Yes. Then I assigned those parameters for all. Okay, for me, all the sections didn't pass. For my case. Did you select them before? Did you select the sections before? Look at this. You select the first one, then shift if I want to select them all. Or if I want, I can use control and select the members, the members which should be made first. I add an replace. Yes, that's what I'm going to see, the bar input for pet beam. So many bars, the bar, have one there, the size, let me put there 12 for example. I came here at RC design. I came here to rebar input for pet beam. I came here to RC design, then press rebar input for plate beam. Are we together? Then okay. We come here to define, suppose we're going to put their name, rebar. How many layers? We need one. The size 1. We'll put there 12. Size 2. For me, I have it. 10, 11. Let me count it. I go to RC. I come here to rebar input for plate beam. Rebar input for plate beam. That moment it was for steelers, but now we are going for all rebars. Yes, for plate beam. You can use that one, but here for rebar, also we have a place where we can put it. You can use this little box. Yes. With what? Yes. Did you check the display of your computer? It doesn't expand.
Sorry. Hello. Hello, Mr. Pierre.
Yes, yes.
I think that's a problem in my software here.
Mm.
I didn't see the size of this bars. For example, for me,
Don't
when
see the
I,
size?
yeah,
Mm.
when I see the bar, example, for this stage which we are here now,
Mm.
for the bar input for plate, for this beam section data for design.
Mm.
When I came here
Yes.
and check the size of stirrup,
Mm.
and the configuration is different, you see, the one which I see here on your screen. Can I share my screen? So
Okay. Mm.
can you see?
Yes. Yes.
The configuration is different, as you see here. But I don't know what is the problem, or I mess up somewhere. And the size here, like you see here, I have 7, 8, 9, 10.
Uh-huh.
I don't have 12 here.
I don't see it. I don't see it again.
You see my screen?
Not yet.
Let me share it again. Now,
Yes.
okay. I'm talking about this section now. In beam section data for design.
No, leave this one. Leave it.
Say?
Close it.
Okay.
Mm. Go to RC design.
RC design.
Go to rebar input for plate beam.
Rebar input for beams.
Then you can see.
When I'm going at a size here, you see the reinforcement size, especially for 12. I don't see. This is all for this input for plates, also rebar input for plate beams, also for beam section data for design.
You see, we have many bars here.
Yes.
That is for many bars.
Because you see my problem, can you share your screen now so as I can understand what you are talking about?
Okay.
Yes, I see now.
Yeah. So I was saying, you see here you have many bars.
Yes. Okay, yes.
You have many bars.
Yes, I know. I see.
Yes. Then, huh? Okay.
I have size 1 and size 2. Yeah.
We have many bars.
Yes.
If here we have different layers, we can put there the number of those layers.
Okay.
So here we'll be having another table for distribution bars.
Yes, I see.
Yes. Then for top and for bottom.
Yes.
Here we have a table for many bars for top,
Yes.
bottom, and their syrups. Okay.
Yes.
I'm explaining this one. Sorry, dude. So here also we have a distribution bars
Yes.
for top, bottom, and syrups.
Syrup. Okay. I get it.
Then we define.
Okay.
Okay.
Yes.
Here you see we can add if it's a first time.
Yes.
Here if we put there if previously we put there the information related to these bars,
Yes.
and after analysis we found that they failed,
Yes.
we can come here, we change the size of the reinforcement, then here you have another option to modify.
Okay.
See?
Yes, I get it.
Yes. Then later you go back to analyze and see if your members passed.
Okay.
Yeah.
But my problem with the sizes of these bars, it differ with me and yours.
They're different.
Yeah. Example, when you score at the
Okay.
size there.
Let me check where there's a problem.
Can I share my screen?
Huh? No, I'm going to check where the problem is. Here there are other people are asking the same question.
Okay, okay.
For many bars. Now we have the many bars in transverse direction, but also have distribution bars, right? So here I kept it one way. Yes, top for top, because I will be having distribution bars. Yes. Then I come here, I choose to work too. Then I choose to CTC, center to center of civil enforcement. Distribution bars. Transit. I have chosen to work for me. Oh yeah. Okay, now we have a slab, right? We have a slab which has the main bars and distribution bars. Okay, on top and on the bottom. So this is what we are doing here. Here I have a tab of many bars. And here I have a tab for distribution bars. For top and for bottom. Is this clear? Or confused again? Okay. Can see it's in meter. The unit is meter. Yes. So what is the problem? It's not clear. So for many bars, right? For many bars, you have a tab for many bars, where you have area of steel reinforcement. But if we put the size of steel reinforcement here, the area will be calculated. I think I was showing that man that in the report they showed the area of top steel reinforcements and area of bottom steel reinforcement. Okay. Then here on top, if I have a slab like this one, I'm supposed to have one layer of many bars. Here, if you look at here at this tab, this one, I have distribution bars at top. So which means that there are many bars at top and distribution bars. Okay. Then I fill them. Here let me put there 0.2 center to center. 0.2. Then for steal-ups, but I say that I have one layer of many steel reinforcement. For size 2, except if I have 2 layers of many steel reinforcement. Yes. So for this DT is cover concrete cover at the top. This DB is concrete cover at bottom. Let's make it 0.0 for example. Then here we make it 0.0.05 at the bottom. Okay. Then here let's put there 0.02. We go to the distribution bars. We have one layer. I'm going to choose. I put there. Yes. Number 4 for goals. But number will depend on the length. I'm keeping it like this, then rotate it. Let me put the one. For distribution size, here distribution size. I keep 10. Then I add my river. Go to center. So there's orders. Okay. 0.02. Then I select. Yes, I added. I perform analysis. Yes. Yes. Can go to design. I close. I perform the analysis because there are changes that I put. Yes. No problem. Yes. So is it the problem for display? This time. So I can see. Let's close the session. I didn't know the time runs like this. Let's close the session we were about to analyze, then tomorrow we start with this point. But the time is too short. Online people, we are closing the session.